Recording is rolling. It is Thursday, August 28th. So, quiz tomorrow. I'll do a review with you guys. And then, if you need extra time in class to finish that circles activity, then you can work on that today too. Otherwise, I'm doing a review for some class, say, right? But here, speaking of circles activity, you guys remember I gave you guys a bunch of circles yesterday, and remind you guys what's going on. I had you guys keep track on a table. Okay, you had circles. Maybe you call them A, B, C, D, F, G, or whatever. Okay. What's the radius of the circle, which you can measure with the ruler? What's the radius? You guys squared that radius, which is going to be helpful for a graph later. You guys took some string and wrapped the string around, and then pull the string and measure how long was the string. So that can give you circumference. And then for the area, I want you to count the number of squares, like the number of tiles. And well, a lot of these are, of course, split in half. So you have to maybe that one to be half a tile, this one to be a full tile. Okay. Okay. And then you guys made 3 graphs on the back. Now, I'm super tempted to give you guys the answers to these, but I want to wait until you guys turn these in because I want to see who figures out kind of where I'm going with this. Okay. So circumference is a function of radius. I wonder what that's going to look like. What is area as a function of radius? And then remember how on the table I had you square all those radial sizes? What if you plot not area versus radius, but area versus radius squared? And that's the third one. Now, there are 2 basic shapes you should see emerge from these 3 graphs. 1 or 2 of these should be linear, and 1 or 2 of these should be a parabola. So those are the shapes you're looking for. And the last thing I wanted you to do was to come up with a couple of equations. So I'm just looking for 2 equations. What's C equals something and A equals something. That's what I'm looking for. Now, really, I want you to come up with equations for linear relationship. Okay, maybe that's a big hint that 2 of these are going to look linear. Right? You guys know how to make the equation of a straight line? Can you find the slope, right? Rise over run? If this was a straight line, could you do rise over run and find the slope? Right? And then say like the y-axis is equal to slope times the x-axis. You guys do that? Right, so that's all I'm looking for. Again, I want to see who gets that all the way. So some of you guys turned that in yesterday, and if you need more time to work on it today, I gave you guys some circles. You guys have the string in front of you. You guys have so you have the equipment you need if you need last time there. Right, but let's look at for quiz review. Quiz review. All right, so what's coming to the quiz is just every day you guys have been here, go home, just write 1 or 2 things. Okay. So let's go back to this abacus. Abacus. Say it's set up. Yeah.
Yeah. I didn't.
Okay, so you turn it.
I turned it and things that I got rid of a little bit. So something that thought we'd get finished, but I thought we'd turn it over.
Okay. Hang on.
I was sorry. I was rushed on time. I thought we.
All right, and we're back. We're back. So let's say write a number here. Let's go. Like that. Guys, what number is that right there? Yeah, that sounds right. 173. So I got 1 in the hundreds place. I got 5, 6, 7 right here. I got 3 right here.
6, 7.
173. All right. How about this? What is that number? 905. So I got 5, 6, 7, 8, 9 in the 100th place. I got 0 here. I got 5 here. So 905. Okay. All right. So you guys can read that with this. You did. Let's do. Okay. Solve for x. All right, go for it. Solve for it.
You first. No, I already heard you not very. Oh wait. No, no. Just reach for it.
All right, who knows the answer? What you got? X equals 3. Oh, yeah. All right, Catherine got it. X equals 3. So I'm solving for this x, which shows up in two places. It shows up here, it shows up here. Okay. Now, this algebra process, there are certain algebra rules. You want to go through a series of steps and sort of undo everything there until you finally isolate x. And the last step says x equals something. Okay. Sometimes there's more than one way to do it. What's a good first step? Distribute. Aha. Distribute this. And then over here, same story. Distribute. So this could be 3x I'm solving for plus 3 times 5 is 15. Oh, yeah. And then plus is 4. Yeah. Okay. 7x solving for plus 7. I think that's the next step right there, right? Okay. Looks like I have 5 terms. 2 of them have the x, and 3 of them are just plain numbers. Ooh, so should I combine my terms?
Yes.
Okay. Maybe I could subtract 3x from both sides. As long as you do it to both sides, it balances the equation. Maybe subtract the 7 over like that. Okay. So here I'm gonna put 4x. And over here, guys, what's 15 plus 4? Minus 7. What? And guys, what's the very last step? Yeah, divide by this coefficient 4. Gives me x equals 3. Alright, you guys see that? Okay. Let's do another one. Same thing.
Might be tricky.
Alright, who knows the answer? What you get?
X equals 2.
X equals 2? Yeah, that sounds right. Okay. So it's the same process we just did. So I'm going to distribute it. So it's like 5x plus 5. I got a minus 23 equals, I got a 2x minus 12. Like that. Maybe I'll get the x's on the left side. So it looks like 3x plus 5 minus 23 equals negative 12. Okay. Here, what if I subtract 5 over and also add 23 over? So it gives me 3x equals, what does all this come out to?
6.
Yeah, that sounds right. It's like 6. Okay. And then the last step is, sorry, better? Yeah, it's 2. Okay. Of course, get an answer, you should be able to plug it back into the original expression and it should make a true statement. Let's see if that's clear. Like after I do some this. So if I take this answer 2 and I plug it back into that x there and that x right there. 2 plus 1 could be 3. Guys, what's 5 times 3? 15. What's 15 minus 23?
Negative 7. Not 8.
Say, negative 8. I'm going to drop that down. I'm going to drop down negative 8. So I should get negative 8 also over here. It's 7 equals. Let's see those here. What's 2 minus 6? Negative 4 times 2 is... it is negative 8. Oh, yeah. In fact, these were equations, like y equals that funny looking expression and y equals this expression, like maybe 2 different lines that intersected. They would intersect at the coordinate 2, negative 8. Yeah, it sure would. Actually, that's the next thing I want to do with you guys anyway. So next one. Let's see. I want you to graph. Okay. But let's do this. Okay. So y equals 3x minus 1. Okay. Okay, let's make two graphs. So it calls like y1 and y2. Let's do 1/3 x plus 7. Okay. We'll put both of those graphs on the same set of axes. Uh, It's a wacky looking graph. Right, so I have two equations. They're each written in slope-intercept form. Got y equals mx plus b, y equals mx plus b. Right. All right, so this first one, y equals 3x minus 1. Where's the y-intercept on this one? Yeah, 0, -1. That'd be right here. Right here. Okay. And if you're ever not sure, then just, because anytime you have a y-intercept, what's always the x value equal to? Yeah, 0. So you could just plug in 0 for x. This would work out to -1 anyway, right? Okay. Hey guys, what's the slope of this first equation? 3. Is that like up 3 over 1, up 3 over 1? Okay. So we go up 3 over 1, and then up 3 over 1. So like 2 right here. Or it could go back 1, down 3. Same thing. Okay. Give me a line, looks like this. Has a slope of 3. Okay. So this is, yeah. Now my x-axis is kind of squeezed for, well, you guys are about to see why. This is like up 3 over 1. Right, rise over run of 3. No. Okay. How about this other equation? Guys, what's the y-intercept on this one? 7. That'd be way up here. Wait, 7. Okay, and then the slope is what? Yeah, 1 over 3. So up 1 over 3. So if you go up 1 over 3, it's like right about there. Okay. What is the x-intercept going to be here? Like, where's going to cross the x-axis? No, guys, this x-axis.
Oh.
Where's this second equation cross the x-axis?
At the origin.
Well, what would the y value have to be?
0.
0, right? Right. Isn't the x-intercept wherever y is equal to 0? You see it? Right. So if you plug in 0 right here, plug in 0 right here, can I subtract 7? And then times 3? -21. Yeah, -21, which is going to be way back here. -21. Right, so equation looks like, graph looks like this right here. So here's my y1, here's my y2. Okay, that's those two equations graphed. Okay. Now, you guys see that point where they cross right there? That point where they cross. If you were given two equations and said solve the system of equations, then graphically that would be the coordinate where they cross, like the xy coordinate. That's the next thing I want to find. Guys, what is that coordinate where they cross right there? What is the coordinate where they cross? Yeah, that sounds right. Just looking at it, it looks like 3, 8, doesn't it? Okay. I think that'll be the point. I think it'll be, I'm going to label that 3, 8. Okay. Now, one way you could solve that is, well, exactly what we just did. You just make a graph and see where the lines cross. Could you also use either a process of substitution or elimination from these two equations? You can do that too. Substitution and elimination. So here, let's review that. So I'm starting with these two equations. Okay. Because if y is equal to this and y is also equal to this, could I substitute out the y sort of and say, yeah, like 3x minus 1 is 1/3 x plus 7. Right, see, I substituted out the y. Right, substitution. Okay. Right, and now, oh, hey, this is kind of what we were doing a few minutes ago. I got 4 terms, 2 of them have the x. I can get like terms together. So should I subtract off 1/3 x here, subtract off the third x here? Maybe add 1, add 1. So something like that, right? Another true? Okay. So I got 3x minus the third x equals, and then 7 and 1 would be 8. Like that. That. Right. Ooh, guys, what about this fraction here? If I want to combine the x's, it should have a fraction that has a common what? Denominator, right? Now, 3, isn't 3 the same thing as 3 over 1? Same thing, right? What do you think the common denominator is going to be here? 3. Right? Now, this one already has a 3 in the denominator, so I'll leave that guy alone. But this guy over here, how can I get a 3 down here without actually changing the term? Yeah, times 3 over 3. Right? Like that. Because that gets the 3 down here, but 3 over 3 itself is 1, so you're not really changing anything, right? Okay. So this is the same thing as 9/3 x minus 1/3 x equals 8. Yeah. Right. And now you can do this. Okay. Because guys, what's 9/3 minus 1/3? 8/3. Yeah. So no, 8/3 x is equal to 8. Okay, you guys good from there? Because now I just cross multiply the 3 and divide it on the 8. Or if you like, I could multiply both sides by 3 8s. That'd be the same thing, wouldn't it? 3 8s, 3 8s. X equals 3. Right. But there's still one more thing we gotta do. Because there were these two equations. And I'm saying that the x coordinate where they cross is going to be 3. But what's the y coordinate? Guys, can I take this x equals 3, plug it back into either one, and they should give me the same y value? In fact, they'd have to. Right? And that would indicate you did it correctly. Okay, so let's try it both ways and see if it works. So we take this 3, plug it into the top equation. So say y equals 3 times 3 minus 1. And that gives me what? 8. Okay. And that should work also for the second one. Y equals 1/3, and then place of x, I'll put 3, and then plus 7. Guys, what's 1/3 of 3? 1 plus 7?
8.
8. It's the same thing. It's the same thing. Okay. In fact, if you treat this as a coordinate, that would be what, comma, what?
8.
Yeah, 3, comma 8. So like over 3 of 8 from the origin, 3, 8. Is that true? Which is exactly what the graph shows. That's 3, 8. Look at that. Same thing. So you guys good on system of equations?
Yes.
All right. Let's do this. Y equals x squared plus 8x plus 16. Okay. There's a few things I want to do with this. Oh, here. Let's start with factor. Can you guys factor that? So y equals. Going to do something kind of like that, right? Okay. Let's go ahead and factor that. You guys remember factor is the opposite process of FOIL, FOIL. So once you think you have the correct answer, you can FOIL and see if it leads you back to the original statement. Kind of backwards process. Okay. And if you need a hint, I'm thinking, what are two numbers that add up to 8 and multiply to 16? 4 and 4. They have to be 4 and 4, right? Which means that, okay, you guys almost got this then. This would be what? Exactly. X plus 4, x plus 4.
That's right.
Which you can also call x plus 4 quantity squared. Be the same thing, but. So if you graph this, let's graph this thing. X-axis, y-axis, 1, 2, 3, 4. 1, 2, 3, 4. Okay. What would that graph look like? Give you guys a head start. Go ahead and draw that graph in your notes. And if you're ever not sure what a graph is going to look like, there's some different techniques you can use to figure it out. Could you make a table of XY values, XY, and then is what if I do? What if I did plug in -4 for X? Plug in -4. What would this work out to? 0. Yeah, guess that's because this would be 0 and this would also be 0, right? 0 times 0 is definitely 0. Right? So if X is -4, Y is definitely 0. That's a coordinate right on the board. Okay. The y-intercept is usually nice to find. Guys, what if x is 0? Then what is y equal to? 1. Yeah. Oh, you have to. Huh?
I have to change for the moment, so how does it look right now? Change.
Oh, yeah. So, okay. You have to go to the gym, right?
No,
This one?
I just asked you early for my dual enrollment class.
Oh.
Yeah.
Okay. Guys, let's try this out. If you plug in 0 for x, 0 plus 4, that'd be 4. 0 plus 4, that'd be 4. What is 4 times 4? 16. Yeah. Right. Which would be, well, that'd be like the edge of the paper. Like if I kept scaling 5, 6, 7, 8, yeah, like way up here, wouldn't it be? Okay. So there you go. So let's try some other points. What if I plug in some points around this -4? Like, how about -5 or -3? I could try those, right? Okay. Let's try -5. What if I plug in -5 here? What does this work out to? -1, and this would also be -1. What is -1 times -1? 1. Ooh, so I know it. -5, 1. That's a point. What about -3? If I do -3 plus 4 is 1 times 1 is 1. Right there. So this is 1, this is 1. Okay. Do one more. What if I plug in -2? What's -2 plus 4? 2? And this would also be 2. Right. So what's 2 times 2? 4. Aha. So point -2, 4. Okay. Okay. So now we got 4 points. Do you guys see what shape this is going to be?
You.
Yeah. Okay. In fact, it was always going to be parallel, wasn't it? Because we got x squared plus something, something, something. Okay. Yeah. So you guys see this is going to do basically this right here. Right? Okay. Yeah, and it would cross at 0, 16, which is like at the top of the paper. It's like way up here. That makes sense too. Right, you guys have that? Okay. What if you're asked the question, how many, here, I'll kind of spell this out. Either how many zeros or how many roots? Or if you set the whole thing equal to 0, how many solutions? Right? That's 3 different ways of phrasing at this point right here, like where's it cross where's the across the cut of the x-axis? Okay. And guys, what's the answer to that question? How many times does it either cross or touch the x-axis? Yeah, just once, because the vertex just barely touches it right here. So the answer would be 1. Is it? Right. And there's another way you can also determine that from the quadratic formula. Now, if I want you to apply the quadratic formula, I would give it to you guys. You guys remember quadratic formula looks like this, right? So we can make a quadratic equation from that parabola equation. So let's go back to the original statement here. If I set this all equal to 0, suppose I say x squared plus 8x plus 16, and I'm going to say equals 0, right? Equals 0. Then I can say x equals, and then I'll just go ahead and write it out. So -b, and I would give the format to you if I wanted you to apply this. -b plus or minus the square root of b squared minus 4ac. You guys know for the a, there's an applied 1 on this x squared. This is all over 2a. So that would be the quadratic equation that applies to that. Oh, yeah. Yeah. Yes. Now, guys, different parts of this quadratic equation correspond to different aspects of that parabola we just graphed. Okay? Like, what is the negative b over 2a? What does that tell you about the parabola? The negative b over 2a represents the x location of the vertex. Right. Okay. Because then there's a plus or minus, and you guys know how the parabola bows like this. So it's like from the vertex, which I just circled right here, you can have a part to the left or to the right of that, and that's what the square root would be. Okay. Let's see if that's true. Okay. Because this is negative b over 2a right here, right? Negative 8 divided by 2 times 1. Okay. Guys, what does that come out to? The part that I circled?
2.
What is negative 8 divided by 2?
Oh,
Negative 4. Negative 4. Okay. So according to what I just said, according to what I just wrote right here, I'm making the claim that the x coordinate of the vertex is at negative 4. Right? And that's exactly what we just graphed right here, because it's the same thing, isn't it? You see that? It's the same thing? Right? There's another part of this. Do you guys remember the discriminant? You guys remember the discriminant? It's like b squared minus 4ac, which is this part right here underneath the radical. Okay. Now, what are you only allowed to take the square root of? Yeah, positive or 0, right? But you can't take the square root of a negative number and get a real solution, right? Then you get to like imaginary numbers, which we're not talking about at this point. Okay? So, so I circled the discriminant. If the discriminant is greater than 0, if the discriminant is equal to 0, or if the discriminant is less than 0, those each correspond to some scenario about this graph. Okay? Okay. Guys, what does it mean? Right, let's start with the middle one. If the discriminant is equal to 0, what does that mean about the graph?
One solution.
Yeah, one solution. One real solution. That's to say 1, 0, or one place where it touches the axis. Okay. If the discriminant is greater than 0, that means it has what? Yeah, 2 real solutions. If the discriminant is negative, that means it has 0 real solutions. Start bringing imaginary numbers and stuff, right? Okay, so what is this? Guys, what is 8 squared? 64? 4 times 16 is what? 64? What is this 64 minus this 64? That would be 0, right? Right? Which tells you which category does this fall into? One real solution. Get that? Because the discriminant 0, right? Which is also exactly what the graph shows. You guys see how the only place this touches the x-axis is at its vertex. There's only one solution. It's the same thing. Okay, same thing. All right. Let's try another one of those. Oh, all right, so new question, but basically the same scenario. So y equals, let's go x squared minus 12x plus 32. Okay, so same thing. Let's make a graph out of this and figure out what the zeros are and the vertex and the discriminant. Let's do the whole thing here. Yeah. Okay. And one process that might help you graph this too is if you factor it. Here, I'll throw that word on the board. Okay, factor, which is the opposite of FOIL. Factor and FOIL are opposite processes. If that could be helpful. Okay. can you fact this thing? Here, I'll start writing out like that too. You say y equals, start going to factored form, something times something like that, right? All right. So what are two numbers that add to -12 but multiply to 32? What do you got? 4 and 8. Aha. Right. Or maybe like -4 and -8. Right. So should I go x minus 4, x minus 8, something like that? Okay. All right. And let's check this. So what if I take what I just wrote and I do FOIL? I should get back to the beginning. So first is x times x is x squared. Outside is -8x, inside is -4x. That brings me to -12x. And then -4 times -8 is positive 32. Yeah, that totally works. That's it. That's the factored form. Okay. Now, from that factored form, you can very quickly get the zeros of the graph. And how do you do that? By setting this equal to 0. Okay. And what would x have to be equal to for this whole thing to be equal to 0? Either what or what? Yeah, it could be 4, because you plug in 4 here, this is a bit of 0, so that zeroes out the whole thing. So 4, right here. Right. Or x could also be equal to what?
8.
8. You plug in 8 here, that zeroes this out, the whole thing's 0. It's right there. So that's 2 points on the graph. Like if I was making a little table like we did before, x, y. I know at 4 it's 0, and at 8 it's 0. So okay. Ooh, guys, what's right in the middle? Like 6? Do you think 6 is probably the vertex of this parabola? Let's figure out what's going on at 6. Guys, if you plug in 6 here, what's this come out to? 6 minus 4 is 2. 6 minus 8 is -2. Right. What is this positive 2 times this -2? -4. So when x is 6, y is -4. Would that be like right here? So there's 3 points on the graph. Okay. But I think that point has to be the vertex because it's halfway between the zeros. Okay. So do you guys see what the rest of the graph is going to look like? Okay. Gotta look like that, isn't it? Problem? All right. So what about in terms of the quadratic equation? Right? How could that help? So go back up here. So I could say where x squared minus 12x plus 32, suppose it was equal to 0. I can say x equals, here, I'll spell it in terms of letters, -b plus minus the square root of b squared minus 4ac, all divided by 2a. And then with this set of numbers, I got a -12. Does that bring me to positive 12? Plus or minus the square root of, let's see, -12 being squared, although negative squared always becomes positive anyway, minus 4 times there's an applied 1 right here. And then c is 32. This is all divided by 2 times 1. All right, there you go. So that will tell you where the zeros are. And again, you know what it's going to be anyway. It's going to be at 4 and 8. Right? So that's the solutions would be 4 and 8. You can try it out if you want. Okay. I want to hone in on what is this part right here. Okay. So guys, what is 12 over 2? What is that? Is that 6? Okay. And what does that represent? Like in general, -b over 2a tells you what on the graph again? Starts with the V. Vertex. Yeah, the x location of the vertex. Remember that a few minutes ago? So I'm claiming that the vertex is at x. So the x location of the vertex should be at 6. Okay. Is that what we just did? Hey, that is what we just did. Look at that. Remember a few minutes ago? Yeah, the vertex was at 6. Guys remember that? Right. And what else? Oh, how about this? B squared minus 4ac. B squared minus 4ac. That's called the what? Starts with a D. Yeah, discriminant. Discriminant b squared minus 4ac. Okay. Now, if that's greater than 0, equal to 0, or less than 0, that tells you something. Remember, if it's equal to 0, it has one real 0. If it's greater than 0, it has 2. If it's negative, it has none. Right, good. So what is this? Here's what's 12 squared? 144. And then 4 times 32, 6,428, I think. Okay. So guys, 144 minus 128. Is that going to be greater than or less than 0? 144 minus 128.
Greater than.
Yeah, I think greater than, right? Greater than? Okay, right? Which means 2 real zeros, 2 real zeros, 2 solutions, 2 x-intercepts. Okay. Which is also exactly what we got in the graph anyway. Okay. Cross this twice. You guys good? Good. All right. Let's do some word puzzles. Okay. Suppose you have a length of rope is 100 meters. I'm going to split it into 3 parts. So, so 3. Well, I'll say 3 parts. Okay. So part A is 5 times the length of part B, and part C, or yes, has 4 times the length of part B. Okay. So, what are the 3 lengths? Okay, so I have A, B, and C. Okay. Let me draw it out, something that might be approximately correct. Okay. Well, let's see. See, A is 5 times B and C is 4 times B. I think A is going to be the longest piece. Okay. So maybe this could be like section A. I mean, C is pretty long, but maybe not quite as much. And then B is something like that. Okay. So maybe this could represent pretty close to that scenario. It could A be 5 times B and C be 4 times B. Okay. And the whole thing has to add up to 100 meters. So this entire length, I'll call it A plus B plus C, has to add up to 100 meters. Okay, so that's the scenario, right? Right there. Okay. Right. In fact, what I just wrote could be one equation in a system of equations. Is if you have 3 unknowns, because right away I don't know what A, B, or C are, but that's 3 unknowns. How many independent equations do I have to set up to be able to solve it? 3. Yeah, I need 3. I need 3 equations. And this could be one of the equations. I know total length is 100 meters. Right? But I need 2 more equations to chase down the exact values. Right? Now, how can I take these sentences and translate those into mathematical equations? What do you think?
A equals 5B.
Yeah. So A equals 5B. And what else?
C equals 4B.
C equals 4B. Yeah, that's it. There's my system right there. Right? I think I can solve the whole thing with that system of equations. Okay, let's go ahead and solve it. Can you guys use substitution?
Yeah, probably.
Um, so what I might do here is maybe combine these 2 facts and say, well, in place of this A, I'll call it 5B. Right, and plus, I got this B, plus, and then instead of C, I'll call it 4B. And that has to add up to 100 meters. Isn't that true? Here's your A in terms of B. Here's your B. Here's your C in terms of B. That would be true, right? Right. Is this, how many B's does this add up to?
10.
10. So 10 B's adds up to 100 meters. Oh, so what is B equal to? 10 meters. Yeah, 10 meters. Okay, so that's one of the lengths of the rope. Be 10 meters. Okay. Now, guys, if B is 10 meters, then what is A and what is C?
It's 56.
Yeah, 50 meters and 40 meters. Because 5 times and 4 times. So there you go. Right. There's all three lengths of rope. 10, 50, and 40. Hey, guys good? Okay. Let's say you have a class of 15 students. And let's say 80% got an A on the quiz. So how many students got A's? Or how many did not get an A? Okay, so number of A's equals number of non-A's equals how many? Aha, 12 and how many didn't? 3. Good, well, 3, right? Okay. Can you guys do 15 students times? Because what is 80% as a decimal?
Okay.
Yeah, 0.80. Okay. Yeah, that's that 12 right there. Okay. And then, well, you could do 15 minus 12 gives you the other 3. Okay. Or the non-A's could also be students. Okay. Okay, what percentage did not get an A?
20.
Yeah, 20%. Okay. And then that would give you this 3 right here. All right, you got that there? All right, so we've got a couple minutes of class left. I'm going to close down this recording. Any questions you have, you can ask me. And yeah, you guys got a few minutes also for circles.